Dear students, Assalamu alaikum and welcome to office.com.pk. Dear students, this is your own platform where you come and learn, and we try to provide you with the best of knowledge we can. Dear students, I request all of you to please do subscribe to our channel and also hit the bell icon so that you can get the videos whenever they are uploaded. Also share the channel with your fellows so that more and more people can benefit from the knowledge we are sharing. I also request all of you to please share your views in the comment section. Your positive views will boost our morale and your negative comments will help us improve the way we are doing. Also, I request you to please tell us what topics you want to study related to chemistry, biology or any other subject that seems difficult to all of you, so that it will be easier for us to decide about video making. So dear students, this is your chemistry lecture, and in the previous video we were discussing about isomerism. Isomerism is a phenomena in which two or more compounds have the same molecular formula but different structural formula. It means that whenever their molecular formula is written, it is same, but when you expand the molecular formula into a structural form, then it becomes difficult, either due to the number of bonds or due to the position of functional groups or due to the length of the carbon chain. There were two basic types of isomerism, the structural isomerism and the geometric or cis-trans isomerism, and we discussed about structural isomerism in detail. I hope that is very much clear to all of you. You can refer to the previous videos if you want to know about the structural isomerism. Today we are going to discuss about the cis-trans isomerism or geometric isomerism. As you can see, the other name of geometric isomerism is cis-trans isomerism. Dear students, whenever two carbon atoms they are joined by a single bond, keep in mind a single bond, then what happens is that these carbon atoms they are capable of rotation, free rotation around that bond. However, when two carbon atoms they are joined by double bonds, then their movement is restricted and they are not capable of rotation, free rotation. Now the position of the carbon atoms and the groups that are attached with them, they are now fixed. This gives rise to our topic, which is cis-trans isomerism. So you have to keep in mind that cis-trans or geometric isomerism cannot exist in the compounds with single bond between two carbon atoms. It will only exist in the unsaturated hydrocarbons. Now let us look at the definition. The compounds which possess the same structural formula, now here there will be same structural formula but they differ in the position of functional groups. The compounds which have same structural formula but they differ in the position of functional groups, they will be known as geometric isomers, and the phenomena will be known as geometric isomerism or cis-trans isomerism. Now the necessary condition for this phenomena to occur. The necessary condition which is a must for this phenomenon to occur is that, or for a compound to exhibit or show geometric isomerism, is that the two groups that are attached to same carbon they must be different. Now 2-butene will be taken as an example. So 2-butene can exist in the form of cis and trans isomers. Let us see how. As you can see, we have to fulfill 4 valency of carbon atoms. Every carbon atom has to fulfill its 4 bonds whenever a stable compound is formed in case of hydrocarbons. This happens because of the specific hybridization. The ground state and the excited state electronic configuration is different. Because of the excited state electronic configuration, the 4 valencies or the 4 bonds become available with the carbon atom to bond with other atoms. So, because of specific hybridization, specific electronic configuration in the excited state, 4 bonds are available and we have to fulfill these 4 valencies. This is CH3, this is CH3, here we have H and H. So as this is a 4 carbon, this will be 2-butene. Because the double bond is present at the second carbon, so it will be 2-butene, and butene because of the 4 carbon atoms. On the other hand, we have another structure, again 4 bonds. Here we have the functional groups. Now this is also 2-butene because again the double bond is present at the second carbon. So but you can clearly see that here the functional group, you can consider it as a functional group methyl or alkyl group. Now the functional group, both methyl groups are present on the same side. Here they are present on the different side. When the similar groups, they lie on the same side of the double bond, on the same side of the double bond. Double bond is the center of importance. When the functional groups, they lie on the same side. Now this is the upper side of the double bond. So when the similar groups, you have to keep this in mind, similar groups, they lie on the same side. Similar groups on same side. And this will be known as the cis form. Now this will be the cis form of 2-butene. Clear? Now here the similar groups are on different sides or opposite side. Of the double bond, so this will give rise to the trans form. This is the trans isomer of 2-butene. Now the rotation of 2 carbon atoms that are joined by a double bond, it could happen only if the pi bond, the first one is the sigma bond and the second one is the pi bond. Now if the pi bond, this bond will break, there will become the single bond. And I have already told you that single bonds, they are capable of free rotation around the bond. So this costs too much energy, making the geometric isomerism possible. Means that in order to, if we want to rotate the atoms around the double bond, we have to provide energy, because we have to break this pi bond so that it becomes single, and the atoms, they are capable of free rotation around the bond. But we cannot provide this much energy, so the cis-trans isomerism becomes possible. That was all about isomerism. I hope this is very much clear to all of you. In the next video, we will talk about the nomenclature of aliphatic hydrocarbons. Thank you so much for your time. Keep watching office.com.pk. Allah Hafiz.